Hi, everybody. Welcome. So I'm going to do a quick video series just on different things that we've learned in computer engineering and electrical engineering. So the learning goal for this lesson is, as a result of this video, you will be able to set up an LED with the correct resistance in a series circuit. So I've got my breadboard here. I got a battery pack. I have a green LED and I have a resistor. Okay. We're going to assume in this class that our LEDs are rated for 20 milliamps. Okay, so let's put that down. Assume rated for 20 milliamps. But then we immediately need to note that this is the same as 0.02 amps, because we're going to have to use this with Ohm's law to actually calculate our resistance that we're going to use. So Ohm's law from up here, Ohm's law, V is equal to I times R, so voltage is equal to current times resistance. So in my case, my voltage is 3 volts. I get that from, I have two 1.5 volt batteries. They are in series, even though they're sitting beside each other. These are in series, so these add up. Okay. My current is equal to 0.02 amps, because that's the maximum amount my LED is rated for. If I go over that, then if I go much over it, it can destroy the LED instantly. If I go a little bit over it, it could just cause it not to last as long as it should. And then my resistance is equal to, I don't know, because that's what we want to figure out. So if V is equal to I times R, then R is equal to V divided by I. And I won't go through the math of that. If you want to see that, ask me in class, but that is the formula I need for that. So I'm just going to have a Python screen here. I'm going to use that to be my calculator here. So my V is 3 divided by 0.02 gives me 150. So I need a resistor that is 150, but then I got to change the units, not kilo ohms, but ohms. Okay. Now, I'm going to try and replicate this circuit right here. Okay. So I'm going from my battery to a resistor to the LED and back. Okay. It really actually doesn't matter if the resistor comes before or after the LED, but we're going to try and follow the circuit diagram, so this is the way we'll do it. So I have put my LED in here. I'm going to put my resistor right here. Okay, so I'm going from positive to the resistors. So this is my power bus here. I will go here, rewire that red. So I'm going from here to here. Now, from the resistor, we go into the anode, which is the positive of the LED. And the cathode will then go towards the ground, be closer to ground. So anode's always closer to positive, cathode's always closer to ground. So from cathode, I will go to my ground bus there. And start simulation, we turn on, we have no warnings. So ways this can go wrong is if I were to hook this up backwards, like so, it won't light. In diodes and light emitting diodes, the power always has to go from anode to cathode, and this one is going cathode to anode, so that won't work. Or if I actually turn this down to 100, it should give me a warning here that I've got too much current going through. Not quite, but if I go much less, let's go down to 50, say. Oh, still no. Okay, as I said, we're assuming 20, but the Tinkercad might be rating them slightly different. If I go 10, I get this little warning here. And I can't use, sometimes you can click on them, it'll tell you what's going on, but there it is. The current through is 58.4 milliamps. Well, it's recommended 20 milliamps, so we are using the recommend one. So we're putting the LED in danger. Now, it's just a fake LED, so we can live with that. But we want to use Ohm's law to figure out our proper resistor levels. So you can also see that our resistor levels, the color code lines up just the way we did that in class. So that is how you set up a LED in a series circuit. Nice and easy. Thank you very much. And the next video will be on inserting a button into this setup here.